Hey guys, what's up, people? Good evening, long time no see. How are you people doing? All of my ICSE friends and colleagues. Yeah. How you doing? Hi Devamita. Hi Madhu. What's up, people? My name is Anoop and this is Vedantu. I hope that all of you guys are doing good and taking care of yourself. Welcome. What's up? What's new in life? Hi Devarpita, I'm good. Hi Durga, hi Bhargavi, long time no see. Hi Madhu, hi, hello Pranav, what's up? Hi Katie, alright, welcome to today's session. I hope all of you guys are doing good. My name is Anup. Once again, this is Vedantu, and once again, today we are going to go with the one shot series. We'll be doing the entire chapter of Force in one go. The whole chapter of Force for ICSE 10th, we'll be doing that today. So we'll have a lot of quiz questions in between. So make sure that you're logged into your Menti as well. Keep your Mentimeter open, and I'll give you the code in a minute. So we'll do one topic. We'll do a quiz question, a couple of quiz questions, and then we'll do one more topic. So we'll have a lot of quizzes in between. It's not going to be like other sessions where we have quizzes in one shot at the end. No, it's not going to be like that. So we'll have the topic quiz will go on like that, right? So before we get started, are you people excited for today's session? Why can't I see any of your chats, duh? Yeah, now I can see it. Yes, that's it, people. That's it. Yeah, no, Abhishek sir's birthday is nearby. Yeah, we'll wish him. We'll make him a good birthday gift and all. We'll give him nice birthday bums and all. You have to give him. Yeah, so that is the only thing that is going on in my head. Anyways, welcome, people. Welcome. We shall begin, people. Our Force in one shot. Now, before we get started, just to get your minds straight, just to give you a good sense of purpose or motivation, this is the quote for today. Sometimes you don't realize your own strength until you come face to face with your greatest weakness. It's a fact. You yourself would have experienced that several times in your life. You might not be able to recollect it right now, but yes, at that time, at that point of time, you would have thought that every other option is fail. But then inside yourself, you've gained that strength, and then you face it one on one, and you're here. So that is all that matters. In fact, 2020 itself was one of the biggest challenge. Which, if someone had told you in 2019 that 2020 is going to be like this, a lot of you guys are told that it's not possible, but every one of you guys made it. So that itself is a big task. So congratulations, people. Keep up the good work and keep moving forward in the same way. So with that said, let's move on to Force. So yes, the entire chapter of Force in one shot. So what are we going to look at in today's session? We'll start with talk and couple, which is one of the basic concepts in ICSE 10th Force. Then we'll understand equilibrium and principle of moments, center of gravity, uniform circular motion, and centripetal and centrifugal force. Amazing topics, amazing session is what is going to happen today. So stay till the end. Make sure that you attend every single question. If you have any doubts, put it down in the comments in the live chat, and I'll try to answer those doubts at the same time as well. So without wasting any more time, people, we shall begin. Force. Alright. In the chat box, before we get started, can anyone tell me what is force? 10 standard. You must be able to define what is force, right? ICSE, that too. Yeah. What is force? Can any one of you guys tell me what is force? According to you people, what is force? Yeah, that's good. That's good. Go ahead. Keep it up. Keep it up. Yes, we'll have Menti also. Work done. Okay. Product of mass times acceleration. Okay. Like a simpler definition. Anyone was force is the motion. All right, Chaitya. Anyone else? The motion. All right. Anything else? Okay. All right. A lot of you guys are saying work done. Force is work done. Force is motion. But in simple words, guys, in the most layman term, you can say that force is nothing but a push or a pull. A push or a pull, which could lead to the change of the state of motion or the change of state of rest. That is what is motion. What is motion? Motion is nothing but a push or a pull that could either change the motion of a body which is already in motion to rest, or which is in rest to the change, or to change it to state of motion. That is what is force. Now, when you talk about force, people, force can generally create or produce two types of motion. One is linear motion and the other is rotational motion. Now, what do I mean by this? Let's take a simple example. Imagine there's a rod, all right, a simple metal rod which is completely free to move. There's one rod and there's another rod which is fixed to an end. So one end of it is fixed. Let's say that I am applying force from below. From below, I'm applying a force on both of these. Now what you notice is that the one that is free to move will move straight. It will show translatory motion or straight line motion. It will not go left or right, but instead it will go straight. So what is happening? The force that you're applying is producing that sort of motion where you see translatory motion or straight line motion. On the other hand, the one that is fixed, the rod that is fixed, will not move straight. Rather, it will start to rotate about that particular point. It will start to rotate about that point. And this point is called as the pivot or the pivot. So what will happen is that it will start to pivot above that point. It will start to rotate above that particular point. And this is what force does. So once again, what does force do? Force, you see, when you apply force on a body, you see two types of motion. Either you see translatory motion where the body moves in a straight line, or you see rotational motion where it starts to pivot above that particular point, or it starts to rotate above that fixed point or that pivot or pivot. How are you going to pronounce it? But that is what happens over here, right? So that is one of the basic concepts of your force. Now we're going to understand. See guys, translatory motion that you've already studied. In your lower grades, you're focused, a lot more on translatory motion, and you're not focused much on, your rotational motion. But this year, that is your ICSE 10th, the focus is more on this rotational motion. So we're going to talk about a little bit more about this. All right, let's say there's again, same thing, same rod, which is fixed about a point. The force that you apply, if you extend a line, if you just start extending it, so wherever the force is, if you just extend that line, that is called as the line of force. So wherever the force is, whichever direction the force is, wherever you're applying the force, if you extend that line, that is called as the line of force. That force is that line is called as the line of force, like common sense, But here's the thing: if you apply a force and that force is passing through the pivot, through the fixed point, then you don't see any motion whatsoever. For example, look at this. You're applying a force over here. About the pivot, about the fixed point, you're applying a force. You will not be able to see any type of motion, movement at all. Here also, when you see this, when you're applying a force from here, again, the line of force is passing through the pivot or the fixed point, and hence you see that there is no movement whatsoever. So you have to understand this, that as long as the line of force is not passing through the fixed point or through the pivot, you will be able to see rotational motion. Otherwise, you will not be able to see rotational motion, because when the line of force is passing through the pivot or through the fixed point, you will not be able to see any type of motion at all. Now, this is a simple concept. Now, this is common sense. Majority of you guys might know about this already, but some of you guys might have this confusion. So to avoid that confusion, that is why I'm telling you this. All right. So understand this, people. As long as it is doing that, you will not be able to see any type of motion. Now, let's talk about one important concept called as torque. What is torque? Let me define that first. See guys, when you apply a force, what happens? Like I told you, when it's not fixed to anything, what will happen is that that force will create translatory motion. I've already stated that the body will start to move in a straight line. But in the case when it's fixed to one end, what you don't see is that it will not go you'll not see translatory motion, but rather you'll see rotational motion. So the force that basically creates this rotational motion, or because of which the body starts to rotate, that is what is called as torque. The measure of that force, that is what is called as torque. The measure of that force, where you see that the body starts to rotate about a fixed point or a pivot or an axis, that is what is called as torque. And mathematically speaking, people, if you want to calculate the value of torque is equal to the force, wherever the force is applied, into the perpendicular distance. What is the distance from the fixed point to the force that you're applying? Whatever is the distance, you measure that, that is what is going to give you torque. Now, the way to denote torque is tau. So you generally represent it like this. It's called as tau. So tau is equal to F into d, which is nothing but force into the perpendicular distance from the point of rotation. So wherever it is fixed, from that distance, wherever you're applying the force, what is this distance into the magnitude of force? That will give you what is known as torque. So if you're asked to define torque, people, if you're asked to define torque, you can define it like this. So torque is defined as the product of force and the perpendicular distance between the line of force and the pivoted end. So simple way of definition. Again, you already know about this, but let's just quickly go through all the definitions. So what is torque? Torque is defined as the product of the force and the perpendicular distance between the line of force and the fixed point or the pivoted end. And the other name for torque is, people, it's also called as moment of force. So if in case in your exams they ask you to find out the moment of force, don't panic and be like, start sweating and all that. It's nothing but torque itself, just that they have used a different term to define it. So torque is also defined as moment of force, and the unit, the SI unit of force is Newton, the SI unit of distance is meter. So Newton meter is the SI unit of torque as well. Now if you talk about the CGS unit, the CGS would be dyne centimeter, the CGS would be dyne and centimeter. So that would be the CGS unit, but SI unit is Newton meter, right? Are you able to understand everything so far, people? All good, all good, all good? Clear? Everything? You're able to understand torque clear so far? Everything? Yes, people. Hi Shail, what's up, buddy? Hi Mini, all good, people? Everyone, hey, all slept off or what? Wake up, wake up, duh. What? Nobody's answering what's happening. Everyone's here, no? All right, I'm not able to see your chat for some reason. Anyways, all right, people. Okay, so that is out of the way. Let me talk about a simple example. Now, all of us have doors. At home, you have a door. Now, what I want you guys to do is, after this session is done, just try out this tiny experiment that I'm going to talk about on your door. Alright, so here's the thing. What you're going to do is apply a force on the hinge of the door. Wherever the hinge is, apply a force. Now what you notice is that the door will not move at all. In other words, there'll be no torque. There'll be no rotational movement whatsoever. Why? Because the line of force is passing through the pivot or the hinge, or in this case, the pivoted end of the fixed point. So in this case, you see that there is no torque. Now, on the other hand, if you apply a force at the very end, just at the end, at the very end, you'll see that there will be plenty of torque. The door will go much more faster. In fact, you don't even have to apply greater force at that time. You have to apply the least amount of force, and you see the maximum torque over here when the force is applied at the very end of the door. On the other hand, when you apply the force in the middle of the door, you see the torque is going to be half, because you have to apply a little bit more force. The torque, because again, what is the formula of torque? Torque is nothing but force into the distance. So greater the distance, greater would be the torque as well. So when you're applying a force in the middle of the door, the torque would be much more lesser in comparison to when the force is applied at the end of the door. And finally, people, when you apply a force, just open the door and try to push it this way, try to do it horizontally, you'll see that there'll be no torque whatsoever. Again, why? Because the line of force is passing through the fixed point. You can actually try this experiment out to make it clear in your mind that this is how torque works. So remember this, people, it's directly proportional. So if you increase the distance, the torque would also increase. Obviously, if you increase the force as well, the torque would increase. The greater the force, greater would be the torque. The greater would be the distance, the greater would be the torque. So lesser the distance, lesser would be the torque as well. So as you see, that is why, guys, when you talk about wrenches, like when you're talking about wrenches and all that, when you're opening something up like a nut or bolt, you always apply for the force at the end of the handle, not in the middle but the end of the handle. Why? Because the torque is much more greater when you apply the force at the end. This is a simple concept again, but you must understand this. Now we've already stated this. How do you define torque? We've already seen this. Don't worry, people, you can download all the notes, so don't worry about any of this. Let's get into the first question for the day and begin our journey of quizzes. So quickly, people, join the Mentimeter, www.menti.com, and enter the code 838771. Like I told you, people, after every concept I'll be asking you a quiz, so do not exit your Mentimeter. Stay here, do not just leave it, because we have about 8 questions back to back. In the sense, once the topic is done, I'll be asking you quiz questions, so make sure that you're in the quiz as well. Get your pens and paper also ready, because there'll be a lot of questions where you'll have to solve these questions. So make sure that you have your pen and paper ready as well. Quickly join the Mentimeter, people, and the code is 838771. So all you have to do is this, people, go to www.menti.com, menti.com, and they'll ask you for a code. So the code for today is 838771, and join the quiz. Quickly, people, quickly. I want all of you guys to be there. Quickly. Alright, people, in the meantime, did I miss out any doubts? Crystal clear? Awesome, awesome. That is all that matters. Yeah, people. Jaren, tell me what is your doubt. Please type your doubt, buddy. Please type your doubt. Exactly, Barbu, exactly. Now, so force can change speed, direction, shape. Exactly. Yes, Tadu. Absolutely, absolutely, absolutely. Yes. Yeah. Who loves tea? What are you taking a Sensex or what? Huh? Sensex or what? Saying a survey. Shreyas? Alright. Anyways. You're a puppy. quickly join the Menti Meter, people. All you have to do is www.menti.com and enter the code 838711. Everyone join the quiz. I don't see a lot of names. Quickly join the Menti Meter, people. If there's any problem, do let me know in the live chat so I can sort it out. I'll try to help you people out. So yeah, everyone's in. Awesome. So we're gonna start, people. I'm gonna start the quiz in 5, 4, 3, 2, 1. Let's go. 8 questions for today. So let's see who's going to be the winner. The first question of force, let's go. A body is acted upon by two forces of each of magnitude F, but in opposite direction. State the effect of forces if the forces act along the same line of action. There are two forces of equal magnitude acting in opposite directions. What would be the effect of these forces if the line of force is also in the same? It's also the same. Your options are: resultant force is going to be 0, the moment of force is going to be 0, there'll be no motion, or all of the above. Let's go, people. Let's see how many of you got the right answer for this question. Okay, what happened? 12 of you guys got the resultant force is equal to 0, but the fact is, people, even the moment of force will also be 0 because it's in the same line of action. The moment of there'll be no torque whatsoever. There'll be no torque whatsoever, and there will not be any motion because the resultant force is 0. It's correlated. If the resultant force is 0, obviously there's no motion because they will continue to be in the state of rest, or if it's in motion, it will continue to be in the state of motion. Why? Why? What is the confusion over here? So the right answer would be all of the above, people. What a blunder. What a silly mistake, people. What a silly mistake. 6 out of the entire class gave the right answer. Congratulations to all the 6 who thought it through and took your time to answer it. So here is your leaderboard at the end of that first question. Rather disappointing one, if you ask me. Joseph was the first to answer, followed by Sanchit, the 9th grader, Jeetunga. Okay, let's see that. Then it's Shizuka, Dhriti, Frosty, and Lola. Unfortunately, a lot of you guys, others chose the wrong answer. Happy Lori, thanks a lot. Bhargavi, high five to you too. Aryan, yes, I do remember you, buddy. Unfortunately, chose the wrong answer. It's okay, it's okay. Moving on to the second question, people. Here's another question for you, people. So here is the second question for the day. Again, it's a problem, so make sure that you get your pens and paper ready and try to do the calculation by yourself. Don't depend on your calculators, because that's cheating. That's cheating. So here's the second question. Let's go. Hi Vijay, what's up, buddy? Long time. So here's the question. Calculate the minimum distance between the point of application of force and the axis of rotation of a rigid body if the force of 125 Newton produces the moment of force of 25.75 Newton meter. Your options are 0.206 meters, 2.656 meters, 0.5 meters, or 0.45 meters. You had 1 minute to solve this question. Right now, you're halfway through. That's about 30 seconds to solve this question. Now, they have given you what is the force. They've given you the magnitude of force. They've also given you the moment of force to be 25.75. You're supposed to calculate what is the minimum distance between the point of application of force and the axis of rotation of that body. Let's go, let's go, let's go. Sir, is pulling easier than pushing? Krishna, it's pretty much the same. It depends on how much what is the magnitude of it. So 10, see, if you're applying 10 Newton of force forward or 10 Newton of force backward, it's pretty much the same. But generally it is like in terms of biology, it is easier to push because your muscles are something which can easily relax rather than contract. So yeah, in terms of biology, yeah, it'll be much more easier. But in terms of physics, you're doing the same amount of work, so it does not make much difference at all. But in terms of biology, if you talk about it, your muscles, your muscle fibers and all, it's easier for you to push something than to pull something, right? So that's all. Anyways, 10 of you guys were able to give the right answer. I think a lot of you guys went wrong with the calculation part over here, that's okay, that's okay. As long as you got the problem, as long as you understood the question and you were able to, at least put on the formula, that itself, if you put on the formula, guys, that itself is going to get you half the mark. So even if you make calculation mistakes, it's okay. So make sure that you put on the formula for every single question that you solve. Even in your boards, it's some practice. It should be a practice, because even if you get the calculation wrong, there's no way to cross check the calculation. You don't have calculators. So please make sure that you write down the formula for every question. All right. So here, the force F is given as 125 Newton. Awesome. The torque, that is the moment of force, is given as 25.75 Newton meter. Now the question is, what is the minimum distance? Now what is the formula of torque? Torque is equal to force into the perpendicular distance. Now torque is given as 25.75. The force is given as 125 Newton into the distance. So what is distance? Distance is equal to 25.75 into 125. So if you divide this, if you want, you can simplify it, multiply and divide by 100. You can simplify it even further. You will get the answer to be around 0.206 meters itself. All right. So that's how you do it, people. It's actually a simple problem. Such three-step question. It's just a three-step answer. Three-step answers. How many of you guys made a mistake in the formula? Tell me the truth. How many of you guys made mistake in the formula? How many of you guys made mistake in the calculation part? Tell me the actual truth. How many of you guys made mistake in the formula? Okay, nobody. I don't believe that. Somehow I don't believe that none of you guys made mistake in the formula. Alright, yeah, a lot of you guys. See, people, remember the formula. That's very simple. Torque is equal to force into the perpendicular distance. So do that, get the answer. Anyways, here's your leaderboard. At the end of that second question, Joseph Dennis is still on the top, followed by Dhriti, followed by Keshav Gandhi, the game changer. Good to know, buddy. Then Chaitanya, Sanchit, Kushi was the first to answer. Congratulations, kiddo. Followed by Shizuka, Kwahish, Griffin, and Bhargavi. High five to you, Duda. Congratulations, people. Well done, well done, well done. That is the end of the second question. So here's your leaderboard as well. Now let's get back to the topic. All right. So let's study a little bit more, and then we'll come back. All right. We'll study a little bit more. Again, we'll come back to the quiz. We have lots of quiz questions. 8 questions there, but you have to stay till the end. Attend every single thing so that you are able to understand the entire chapter in one shot. That is the whole point of this, right? Okay. Let's get back to the topic. What I'm going to talk about next is called a couple. All right. Not the couple that you guys are thinking of. This is the couple in physics. Now, if you type the word couple in Google also, it will show you something else altogether. All right. But I'm talking about the couple in terms of physics. Now, what is couple? See, guys, in simple words, couple is nothing but the rotational motion caused by two forces equal in magnitude but opposite in direction, and the line of force is the same. What do I mean by that? Imagine I have a steering wheel. Imagine I have a steering wheel right in front of me right now. All right. Now, when you're trying to rotate that steering wheel to the left or to the right, what do? One of your hand will go up. The other hand that is there will pull it down. So you see that there's one clockwise, basically it's clockwise movement. So you see that one is pulling it upwards, the other is pulling it downwards. Now, the force that you apply will be equal in terms of magnitude, but opposite direction. One is going up, the other is coming down. And what you notice is that it starts to rotate about a fixed point, or we call it as an axis. So about that axis, it starts to rotate. And more importantly, the force that you apply, the line of force that you apply will be the same for the same. Basically, when you hold the steering wheel, you hold it like this. So when you rotate it, you see this one is going up, the other is coming down. So the force are equal in magnitude, opposite in direction, and the line of force is acting, basically it's in the same line of force, and that is what creates couple. Now this movement that you see, that can be called as moment of couple. That movement that you see either clockwise or anti-clockwise, that is called as a moment of couple. This is what is couple. In simple words, this is what is couple. When you hear the word couple, think about a steering wheel or think about a seesaw. Any of this you can use that as an example. Steering wheel is much more easier because you'll have probably seen it at least in movies. Maybe none of you guys are of the age to drive a car, but at least you've seen it in movies how people rotate the steering wheel and all that. So it's much more easier to relate it that way. So forces which are equal in magnitude, opposite in direction, in the same line of force, that is what creates this rotational motion, which is called as couple. Which is the rotational motion, the turning effect is called as a moment of couple, and the formula to calculate it is very, very, very easy, people. So if this is the let's take this whole distance as d, and this is the force is F. So the formula is very simple. Couple is represented as the letter C, capital C, is equal to any of the forces, any of these forces. Either we'll take this as force 1 or F2. So either of the two forces, either of the magnitude of the two forces into the distance between the two forces. So the entire distance d, basically it's like torque itself, but then this time you're not taking the distance with the fixed point, but the entire distance where the force is applied. That is what is how you calculate couple. Now you have two types of moment of couple. One is clockwise moment, where you see that the rotation happens this way, and anti-clockwise moment is where you see the rotation happening this way. So when the force is like, basically when you're turning left, that is anti-clockwise moment, and when you're turning right, that's clockwise moment. It's rotating towards, I mean, it's basically rotating this way, that is clockwise, and when it's rotating in the opposite direction, that is called as anti-clockwise moment. Now again, depending on which direction it's moving, the force applied will also be different. So you see this, when you want clockwise moment, this side would go up, this would come down. When you want anti-clockwise moment, this would go up and the other would come down. Simple, right? Such an easy example to explain such a easy concept. So moment of couple is equal to either of the two forces into the perpendicular distance. The perpendicular distance is nothing but this whole distance, which is nothing but, you can, here in this case it's nothing but 2d. So 2d into either of the two forces, either of the two forces. You have to take both the forces. Either you take it as F1, either you can take it as F1 into 2d or F2 into 2d. Right guys? Did everyone understand what is couple? Is it clear? Is it clear in your mind what is couple up? Are the ones not acting along the same line? No, in this case it does acting in the same, it does act in the same line. Right? It is acting in the same line, right? It is, definitely it is. That is how you say that it's couple. If it is, if you are, either, see, whatever it is, when you're holding a steering wheel, you always hold it like this. You don't hold it in, they tell you that, 12 o'clock, 1 o'clock, I don't know, because I don't know how to drive, but you always hold it like this. You don't hold it like, what to say, this around. Even if you hold it like this is still, it's going to be the same line of force itself. Whichever direction you hold, it's going to be the same line of force itself. Alright? Anyways, so that is pretty much it, people. With that said, let's get back to the questions. Let's get back. So here is your next question regarding couple. Now quickly join the Mentimeter. I see a lot of you guys have joined just right now, so quickly join the Mentimeter. Enter the coupon code enter the code, I'm so used to coupon code right now, so enter the code 838771 and join the Mentimeter so that we can begin the next question. So quickly, we have done only 2 questions, people. We have 6 more to go. So if you have if you've just joined right now, quickly join the Mentimeter. You still have a chance to get on the leaderboard, because the first 2 questions were unfortunately slow. A lot of them got it wrong. So quickly join, people. Quickly. Yes, I am BTech. I did BTech only. Oh, nice, Anushri, nice. Quickly join, people. Quickly, I'll give you another 5 more seconds. All those who haven't joined, quickly join the Mentimeter. I see a lot of names in the chat box, but I don't see them in the Mentimeter. So quickly join, people, so that you can take part in the quiz rather than just typing it out in the live chat. You can at least get some points and have some fun in the Mentimeter. So quickly join it. So I'm going to be starting the quiz in 5, 4, 3, 2, 1. Third question regarding the moment of couple. Here we go, people. The question is: calculate the magnitude of force of a couple when the arm of a couple is 63 centimeters and the moment of couple is 21 Newton meter. Calculate the magnitude of force of a couple when the arm of a couple is 63 centimeters and the moment of couple is 21 Newton meter. Your options are 50 Newton, 44.7 Newton, 25.5 Newton, or 33.33 Newton. Let's go, people. Let's go. Now, all those who haven't joined the Menti, quickly try to join it, people. All you have to do is this, or for all the new students out there, all you have to do is this: go to www.menti.com, menti.com, and enter the code 838771 and join the Menti. Enjoy yourself. Do it, people. Let's do it. Yeah, Kashi, you did. Awesome. Did you answer the question also? Hi, Arada, what's up? Long time. So, where you were, Abhi sir? Batchmates? Yes, Keshav, we were classmates, benchmates. Yeah, best buds. You can call whatever you want. Anyways, hi Chinmay, what's up? Chinmay Kumar, what's up, buddy? Welcome. Hi Dhirender, what's up? Hi Harshita, what's up? 15 of you guys were able to give the right answer for this question. That's actually by far the highest that we have gotten. So yeah, congratulations. It's a rather disappointing number, but still that's the highest that we have gotten so far. Let me just answer this question, people. It's actually quite an easy one. Once again, the formula is very simple. Couple is equal to the force or the moment of couple. You can don't write as just couple. Moment of couple is equal to the force into the distance between the forces. The distance between the forces So here they're asking you to calculate what is the magnitude of force. So they've given you they've given you the distance as 63 centimeter. Now look at this, people. They've given you the moment of couple as 21 Newton meter, not in terms of centimeter. So convert this to meters first. How many of you guys made this silly mistake of not changing or not checking the units? Tell me the truth. How many of you guys did not change the unit from centimeter to meter? How many of you guys made this mistake? Katie, why? Look for these silly these things. Why are you losing marks for all of these things? So by now you should be able to do it by without any sort of mistake. All right. So let me just come back to that distance. So D is equal to 63 centimeter in terms of meter. That is divided by 100. So that's 0.63 meters. Now put it down in the equation. So 21 Newton meter is equal to F into 0.63. So F is equal to 21 divided by 0.63. If you divide this, you'll get the answer as 33.33 Newton. That is the answer, people. Such a silly three-line answer. Easy to mark in your back, people. If you do not make such silly mistakes, it's such an easy question. Nonetheless, here's your leaderboard. Let's see how many players in the top 10 got it wrong. None of you guys. That is actually a good sight. Not a problem at all. I think Sanchit got it wrong. It's alright, Sanchit, no worries. Joseph on the top, followed by Keshav. Then it's Dhriti, Chaitanya, Kushi, happy Lori to you, Tuda. Then it's Shreya, Dr. Evil, fastest to answer. Congratulations. Adarsh, high five to you, buddy. And then Sanchit as well. Congratulations. Well done, people. Well done. With that said, moving on to the next question regarding the same again. This one actually is going to be one of the most easiest questions. So read the question carefully and then answer. Let's go, people. Come on. Read it very carefully and then answer. It's a simple question. The question is this: two forces, each of magnitude 10 Newton, act vertically upwards and downwards respectively at the two ends A and B of a uniform rod of length 4 meters, which is pivoted at the midpoint O as shown. Determine the magnitude of the resultant moment of forces about the pivot O. Go for it, guys. Let me know what is the answer. So two forces each of magnitude 10 Newton act vertically upwards and downwards respectively at the two ends A and B of a uniform rod of length 2 meters, each of which is pivoted at the midpoint O as shown. Determine the magnitude of resultant moment of force about the pivot O. Your options are 20 Newton meter clockwise, 20 Newton meter anti-clockwise, 40 Newton meter clockwise, or 40 Newton meter anti-clockwise. Let's go, people. Come on, 9 more seconds. Such an easy question. Let's see how many of you are able to do this. Let's go. Yeah, Ayush, confidence. I like it. I'm good. How are you guys doing now? Welcome. Got it? Awesome. 18 of you guys were able to give the right answer. Congratulations, people. Congratulations. Beautiful number. That is actually so much better than how we have done so far. So yeah, people, it's such an easy question again. Okay, there's no space for me to write, so I'm going to write it right here. So people, now there are two ways to do it. Either you directly use the Kapilwala formula. Alright, directly use the Kapilwala formula, which is nothing but either of the two forces, so 10 Newton into the distance between the two forces is 4, so nothing but 40 Newton meter, and the direction is definitely going downwards and this is going upwards, so it's clockwise direction. So you can do it this way. This is one easier way to do it. But the right way to do it, they are asking you to find out the moment of forces. Alright, they're not asking you the moment of couple, they're asking you the moment of force. So what you will do is, you can find them out individually. That is, find out the moment from this force about this point and find out the moment about this that is applied by this force about the point O. So force applied, or the moment of force, you can say moment of force by A at O. So that will be what, 10 into what is the distance. So they've given you that it's exactly kept at the midpoint. The pivot is at exactly the midpoint. So what is this distance in? This distance will be 2 meters because the entire rod is 4 meters, and this will also be 2 meters. So what will that be? 10 into 2, which is nothing but 20 meters. You're finding the torque basically. You're finding the torque. So what is torque? Torque is nothing but force into the perpendicular distance, or the perpendicular distance from the fixed point. So here it's nothing but this distance, 2 meters. So you get it as 20 Newton meter. And again, moment of force by B at point O. So moment of force by B at O. So once again, 10 into 2, you'll get it as 20 Newton meter. So what is the total moment of force? total moment would be 20 Newton meter plus 20 Newton meter, which is nothing but 40 Newton meter clockwise. This is the right way to do it. Now, depends on how they're asking you. If they ask it as a 1 mark question or 2 mark question, maybe they might ask it as a 2 mark or 3 mark question. If they ask us a 2 mark question, then probably you can go with this one, directly write the answer, because ultimately you're producing couple itself. But if they are asking you in specific that you have to find it in terms of moment of force, then I would suggest you people to go with this method rather than directly using the couple wala formula. Use this method, find out the individual moment of force, and then add it both up. You'll still get the same answer, that is 40 Newton meters. Got it, people? Did you understand? Did you understand this? Very important. Again, they might ask you this just to throw you off track. Simple question, just requires a little bit of thinking, and you'll get the answer. And I could see that in the overall result as well. A lot of you guys got the right answer. Let's keep it up, people. So here's your leaderboard once again. Joseph is like not giving up his position at all today. Joseph is like full on going like a super fast Shatabdi Express. Followed by Keshav, then it's Dhriti, Chaitanya. It's Chaitya. Sorry, Chaitya, Kushi, Happy Lori. Then it's physics versus biology 20 meter. All right. Shreya, Ganesh, and homophobic what? Himanshu. Okay, alright. Anyways, I'm gonna ignore that. Nonetheless, so people, with that said, before we move on to the next question, let me ask you this question. Are you people enjoying the session so far? In the chat box, if you are, give me your oh yeah. Are you guys enjoying the session so far? All good? Everyone enjoying? Relax yourself? Yeah? You guys are able to understand everything? Everything okay so far? Yes or no, people? In the chat box, no? Why is the word? Yeah? All right, guys. Okay. So, if you want to have more such amazing sessions every single day and want to have a lot of fun doing that and also gain 100% knowledge and 100% mark in your board exams, ultimately that is what you're striving for, right? All you gotta do is click on the link that is given in the description as well as the pinned comment section below. So this link would take you to the Vedantu website. Well, let me tell you what are the advantages before you start clicking on the link and going somewhere else. Let me tell you what are the advantages. Here's the thing, guys. Once you click on that link and you enroll into the courses, you have the opportunity to learn with the best of the best teacher, unlimited live classes without any sort of limit put on to how many sessions you're attending. With that, every single session would have the highest level of quizzes like what we just did right now, and obviously you're gonna have a lot of fun studying the same concepts that you're doing right now. With all of these, you also have the opportunity to compete with the rest of the world when you do the quizzes, because it's not just your state or just the country. You have students from all over the world and you have the opportunity to compete with them and check where you are at. You sometimes feel like you're the best. So this is your chance to compete and check if you're really as good as you think you are. And added to this, people, you can also attend the live interactive replay session. So if in case you miss out a session, let's say that because there are sessions going on 24/7 and it's very obvious that you might not be able to attend all the sessions, even if you miss out a couple of sessions, it's okay, no worries, because you can still take part in the interactive replays. You can still end up taking the quizzes and check out the leaderboard of every single session. With all of these, you can download all the premium content, watch the replay of every single session, how many of a number of times you want, and get every session's handwritten note of every single teacher. So you never ever miss out on something that is important, because everything is at your grasp. You can download it whenever you want, watch the replay and check out the the content, the handwritten notes of every single session. Or added to this as well, people, inside the session you will not just have the master teacher, but in fact you have two teachers, the master teacher and the class teacher, to help you clear every single doubt of yours. So you never walk out of the class with a confused state of mind, because we have constant teachers helping you to clear your doubts. That is the class teacher, and then you have the master teacher as well to help explain the concept and help you clear your doubts. And it's not done yet. With all of these, you also have 5,000 micro courses and crash courses, all for free. Once again, guys, You will be having the opportunity to study with the best of the best teachers all across India, across the globe, in fact, and you have the opportunity to make yourself one of the make yourself the best use of your time that you have. Whatever time you have left, about 4 months, you can make the best use of that. Click on the link that is given in the description and use the coupon code AME Pro. This is my coupon code AME Pro to avail your discounts. So why am I saying this, people? If you go for the 1 month program, that's about 2,699 rupees a month. But if you use the coupon code AME Pro, you get a discount of about 500 rupees, and the price comes down to 2,159. I know 500 seems like a less amount of money, but then it's still some savings and you can use it for later purposes. And also, if you go for the 3-month program, that's worth 6,999. If you use the coupon code AME Pro, you get a discount of 1,400 rupees, and what you're essentially paying is 5,599 rupees. Now, when you think about it, it seems like a lot of money, but think about it, people. In that 1 month duration, if you think about it in terms of value of money, you would have attended roughly about 250 sessions. And if you talk about the 5,599, the package that is for the 3-month the course, that's about 750 sessions in those 3 months. That means that per session you're roughly paying about 9 rupees for the 1 month program, and for about 7.5 rupees for the 3-month program, which is actually quite a lot less. In fact, lesser than a packet of laces. Think about it, people. It's for your own future. You're investing on your own future to again to make the best of your board exams, to to score those 90%, 80%. Because I'm pretty sure that every one of you guys here are serious about studies and you want to score that 90%. You want to make your parents proud. So yeah, why not use this opportunity to make that happen? Again, the link is given in the description. If you're someone who has not started the revision yet, if you're someone who's who's not started studying at all yet, does not matter what category you are under, it's okay. We will do our best to help you guys out, to make sure that you guys do your best. We'll also give our best, you also give your best, and yes, people, together we'll be able to make it happen, right? So the coupon code is AME Pro, and the link is given in the description as well in the pinned comment section. So with that said, people, let's get back into the topic. Let us now understand the rest of the topic. All right, so listen up now. Focus up. I know all these distractions. Let's get back to the topic right now. Okay, equilibrium. Now, before I start this topic, can you tell me what comes into your mind when you hear the word equilibrium? What is the thought that comes into your mind? The first thing that comes into your mind when you hear the word equilibrium? Anyone? Equilibrium heats, it's all Hi, Siva. Anyone who has any thoughts when you hear the word equilibrium? Anyone? Any ideas that comes in your mind? Equal. Okay, the word equilibrium has the word equal in it. All right. Balance, squash. That's a very good way of looking at it. Harshita is like smiling. All right. Equal. Dynamic, static. All right. Bhargavi, you've already stated what I have to start about you to teach also. Equivalence. All right. Now, no, not bad. It's not bad. Actually, a lot of good terms you've been using. So, what is equilibrium? Equilibrium is nothing but a state of balance. A state of balance is what is equilibrium. It is what is equilibrium. Now, in physics, people, there are two types of equilibriums. You have static equilibrium and then dynamic equilibrium. To give you a simple example, to give you an idea of what is equilibrium, imagine there's a box, all right, so with some mass m. Now, let's say that there are two people. Let's take two examples. We have Yashvi, who's standing over here and pushing this box, and on this side we have Aruna standing over here and pushing this box. All right, so both of them are giving their best and giving about 10 Newton each. Their best is 10 Newton because they're very, very strong. They're like the next blue Hulk and green Hulk. That's how it is. All right, so they're applying a force of 10 Newton from both the sides. Now, if you look at this, both of them are applying a force of 10 Newton in the opposite direction. Aruna is applying the force from here, and Sneha is applying for the force from here. Both of them are applying a force, and they're equal in magnitude. Both of them, the force that they're applying is equal in magnitude. So what will be the resultant force? What will be the net force acting on it? Because they are acting in the opposite direction, the net force will be 10 minus 10. Why? Because it is in the opposite direction. So what will be the net force? Net force will be 0. So when you attain a net force, when the net force is set to be 0, that is when you say that the box is in equilibrium. Why? Because when you are applying a force from both the sides and it's in the same direction, it's in the opposite direction of the same magnitude, what happens? You don't see any sort of motion. The box will remain in its same position because there is no external force. The force that they are applying is cancelling each other out. They're cancelling each other out. So there's nothing in fact, in terms of physics, there'll be nothing. The net force is going to be zero, and hence the box is said to be in equilibrium, which means that the box will continue to be in the state of rest. Now, this is one simple example to explain what is equilibrium. Now, if in exams you're asked to define equilibrium, this is how you define it. When a number of forces acting on a body produces no change in the state of motion or rest, change of state of motion or rest, that is when the body is said to be in equilibrium. So there are three key words that you have to focus on. One is there are a number of forces acting. It's not just one force, it's a number of forces acting on it. Second, there is no change in the state of rest or motion. Then and only then you can claim that the body is said to be in equilibrium. Simple, guys. That is how you define equilibrium. As I was saying, there are two types of equilibrium. One is static equilibrium, the other is dynamic equilibrium. Static equilibrium is basically when a body is already in the state of rest, and again, two people are pulling from both the directions. Again, let's say that the magnitude of force is the same. So he's also applying 10 Newton force, he's also applying 10 Newton force. So what will happen? The net force on this body would be zero, and what will happen to the box? Will the box move or will it stay as it is, people? What do you think would happen to the box? Would it move or would it stay the same when both of them are pulling with the same amount of force, the magnitude of force is the same? Exactly, it will stay right there. This is what is said to be static equilibrium. That is, when you see that the forces acting on it remain, or the body remains to be in the state of rest, that is called a static equilibrium. Dynamic equilibrium is when the body is already in motion. For example, if you talk about an airplane, so there are four forces acting on an airplane. So you have thrust, which is acting in the which is pushing the airplane forward. You have drag, which is pushing it backward, which is nothing but a form of friction, air friction, that is nothing. And then you have the lift, which is going upwards, and weight, which is pulling it downwards. Now, an airplane, once you reach a certain altitude, so what do the pilot do? They put it on autopilot mode. So what happens to the airplane? The airplane will continue to move in the same speed or the same velocity. It will not change the velocity at all. It will continue to move with the same velocity. Why? Because thrust will be equal to drag and lift will be equal to weight. So because they are all equal, what happens? The net force is zero, and hence the body will continue to move in uniform motion. That is when a body is said to be in dynamic equilibrium. So when the number of forces acting on it will not change the state of motion. When the body continues in that uniform motion, that is when you say it as dynamic equilibrium. So if you have to define what is static and dynamic equilibrium, it's very simple. So static equilibrium is nothing but when a body remains in the state of rest under the influence of several forces, that is called a static equilibrium. When a body remains in the state of motion under the influence of several forces, that is called as dynamic equilibrium. Simple, no? Such simple concept. Did every one of you guys here understand this concept? Jared, please type it out and tell me what is your doubt. Hi Mahendrapal, what's up? So people, did every one of you guys understand this? Yes, I do, Katie. Yeah, unfortunately, yes. Yeah, people, clear so far? All good? Jared, please type it out. Don't tell me doubt. I'm not God to guess what is your doubt. So please type what is your doubt. Tell me what is your doubt so that I can clear it, alright? So yeah, people, in conclusion, this is what you have to understand. To attain equilibrium, there are two things that is very much needed. One is that the net force should be equal, that is equal to zero. The resultant of all the forces, the net force should be zero. That is when you can say that the body is in equilibrium. If in case the body, let's say for example a seesaw, all right, a seesaw would be basically pivoted about a point, a midpoint. Here you can claim it to be in equilibrium when the moment, the algebraic sum of moments of all the force is basically zero about that fixed point. That is when you can claim it to be in equilibrium. That is in the case of a seesaw, or when you are, if in case it's balanced by a particular point or it's fixed at a particular point. When can you claim that it's in equilibrium? When the moment of force is equal to zero, when the resultant moment of all the force is equal to zero, that is when you can claim that it is said to be in equilibrium. So with this in mind, people, with the second point, let me will get into the next topic, that is the principle of moments. One of the most important concepts from which you can expect a lot of questions in your board exam. Principle of moments. In the most simplest term, principle of moments at equilibrium is when the sum of clockwise moment is equal to the sum of anti-clockwise moment. That's all. The sum of clockwise moment, when it's equal to the sum of anti-clockwise moment, that is when you say the principle of moment is said to be in equilibrium. Now, how do you calculate that force? How do you calculate the moment? Again, it's nothing but torque itself. It's nothing but force into the perpendicular distance. So here the force is nothing but weight. So W1 is nothing but the weight of the first boy, and W2 is nothing but the weight of the girl. So W1 into R1, which is nothing but the distance from the fixed point, and W2 into the distance from the midpoint or from the fixed point, that is nothing but R2. So you're basically finding out the torque. When the clockwise moment is equal to the anti-clockwise moment, that is when you say that it is said to be in equilibrium. Because just look at this. So when the boy, as he goes closer to it, what is happening is that he's counteracting whatever force is applied by the girl. So at a certain distance, what is happening? There is complete equilibrium attained. There is no movement whatsoever, because the principle of moment at equilibrium is basically it has attained equilibrium when the sum of clockwise moment is equal to the sum of anti-clockwise moment. Now, how do you find out the clockwise and anti-clockwise moment? Basically, you're finding out torque, the moment of force itself. So torque is nothing but force into perpendicular distance. So here also you're doing the exact same thing. When it's equal, that is when you have attained equilibrium. Understood, people? Is it clear? 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 All good, all good, all good, people. Did everyone of you guys understand this? Please type it also and send it to me. I'll just finish off this topic. We're almost done. Yeah, we are almost done. We are almost done, people. A little bit more, and then we are almost done. We have a little bit more, that is circular motion and centripetal and centrifugal force. We're towards the end. So once we're done, you guys can ask me whatever doubts you have. I'll try to clear it up. Just a little bit more time, people. Hold on, because we're doing the entire chapter of force. So it might take a little time. Please be a little patient. But nonetheless, here's your leaderboard at the end of that question. Joseph, for the previous question, Joseph, Keshav, Dhriti, Chaitya, Kushi, Happy Lori, Physics, then Shreya, Ganesh, and Himanshu as well. Moving on to the fifth question for the day, people. Once again, all those who went out of the quiz, quickly join back the Mentimeter. www.menti.com and enter the code 838771. Voila, people, quickly join. Quickly. So we need class 9 one-shot series for physics. Sure, Channa, don't worry, we'll be coming out with that also. Once we're done with physics of ICSE 10th, we'll be starting off with CBC 10th and CBC 9th as well. Don't worry, alright? Sure, Jasmine, don't worry now. Don't worry, that is why we're here. No. Alright, people, so I'm going to start the quiz. Quickly join the Menti. Why is no one joining the Menti? Quickly join, quickly. What are you doing here? Sitting and hatching eggs or what? Warming your seats up. No, quickly join the Mentimeter. www.menti.com and enter the code 838771. So quickly join the people, and then we'll move ahead. Come on. Alright. Jaren, chill out. Thank you, Shum. Thanks a lot. Alright, people, so I'm going to start the quiz in 5, 4, 3, 2, 1. Because, alright, here we go. Fifth question. Take a look at this one. Simple question. Two unlike forces, parallel, of 10 Newton and 25 Newton, act at a distance of 12 centimeter from each other. Find out the point about which the body will balance. Amazing question. Two unlike forces, not like forces, unlike forces, parallel, of 10 Newton and 25 Newton, act at a distance of 12 centimeter from each other. Find the point about the body will balance. Find the point about which the body will balance. Your options are 6 centimeters, 3.43 centimeter, 4.3 centimeter, 4.5 centimeters, or 3 centimeter. First of all, guys, to solve this question, draw the diagram. If you draw the diagram, you'll find this question to be super easy. But if you don't do the diagram, the whole thing will start crumbling down. You'll get super confused. So make sure that you do it right. Draw the diagram for your own reference. It could be however dirty you want it to be, but make sure that you draw the diagram and then solve the question, right? Done, people? Awesome. Yeah, Kushi. Alright, Jared, I know, right? It's super easy question. No, exactly. Nonetheless, 10 of you guys were able to give the right answer. That's not even 50% of the class. Now, what is happening? What is running in your head, people? Okay, but it's okay. Understandable. It's an understandable question. So don't worry. First thing, people, like I told you, draw the diagram. So I have, okay, my God. Yeah. This is what I meant. Don't draw it like this. All right. So let me just draw it clearly. Wait. So there's this. All right. Okay. So there's a let's say that's the midpoint. One force is acting downwards, 10 Newton. Now it's parallel. So this other force is also basically like this. Now here's the thing. They've told that the distance between the two forces is about 12 centimeter. The distance between two forces 12 centimeter. So I'll just take it somewhere over here. So that's about 12 centimeters, I believe. From this point 12 centimeters, somewhere about there, you have your 25 Newton force also acting. Now they're both parallel, so they're both acting downwards. Alright. Now you are supposed to find out at what distance would the body be balanced. That is the question, right? So this whole distance between them is 12 centimeter. Alright, so I'll take this distance as x, alright, because I don't know what is the distance. So this distance will be what? It'll be 12 minus x, because the whole distance is 12, and the distance, the other distance that is there is x. So it'll be 12 minus x. Now, find out use the principle of moment wala formula. Find out the answer. So what does the principle of moment wala formula say? It is nothing but the clockwise moment is equal to anti-clockwise moment. So that is nothing but 10 into 12 minus x, which is again clockwise moment is equal to anti-clockwise moment, which is equal to 25 into x. Simple. Now simplify the equation. So you'll get it as 120 minus 10x is equal to 25x. You're just using principle of moment wala formula. Whereas what does the principle of moment at equilibrium say? It is nothing but the sum of clockwise moment is equal to sum of anti-clockwise moment. That is what it means. And how do you find out the moment? It is nothing but force into perpendicular distance. So here the force is 10 Newton. Perpendicular distance from the midpoint is nothing but 12 minus x. For this one, it's the force is 25 Newton, and the perpendicular distance is nothing but x. So you put that over there and get the answer. Very, very simple. Now you'll get a quadratic equation, I believe. So you solve for x. I don't think you'll not even get, it's not a quadratic equation also. So you have 120 is equal to 10 goes to the other side. So that's 35x. So minus 10 goes to the other side, plus 10. So 25 plus 35. 10 is 35x. So x is equal to 120 divided by 35. 5 7 35, 5 2 10, 5 4 20, 7 3 21, 3 point, that'll be 3, so that's 3 point something, 3 point, how much will be 3.43, alright, 3.43 centimeters would be the answer. Did every one of you guys understand this question? Was it difficult? Tell me the truth. Was it actually difficult? Was this question actually difficult? Like once you understood the answer, was it actually difficult? Seriously, Rhythm, is it actually difficult? It's such an easy question. Such an easy question. It's just that you have to use common sense. That's all. So make sure, guys, when you are asked these kind of questions, draw the diagram first. Once you draw the diagram, the whole thing will be clear in your head. Then you can go ahead and do the whole problem without any sort of hindrance, because you know what the diagram looks like. You know what to do there. Alright. Nonetheless, Joseph unfortunately chose the wrong answer after such a long streak. Unfortunately, Joseph goes to the third position. Keshav was the fastest to answer, goes to the top, followed by Dhriti, followed by Chaitanya. Then it's okay, Joseph, then Chaitya, Kushi, Himanshu, Shreya, Koish, Happy Lori, and physics versus biology. Congratulations, well done. Keep up the good work. With that said, moving on to the topic, people. Let's get back to the topic. That is center of gravity. Everyone, focus up. Come back to the chapter. A couple of more minutes. Give me like 5 minutes. That's more than enough. Center of gravity. Now, what is center of gravity? Now, here's the thing, guys. We know that Earth has a force by which it pulls anything towards the center of the Earth. And that force is called as a gravitational force. Now, what is this gravitational force? It's nothing but the force by which Earth pulls anything towards the center of the Earth. When you have a ball or an object, what happens is that there is a force acting on it. And what is the amount of force that is acting on it? How do you measure that force? That force is nothing but the weight of the particle. That force is nothing but the weight of the particle. What does weight tell you? The weight tells you what is the force, the magnitude of force by which the Earth is pulling anything towards the center. Weight is what? It's a quantity that tells you how much amount of force is acting on that body due to the Earth's gravitational force. That is what weight tells you. Now, here's the thing, guys. There is a point for on every object, on every single object, regular, irregular, it does not matter, including planet Earth. There is a point where the entire mass or the entire weight is acting. Like for example, imagine I have a cube. So there is a point on this cube, where the entire weight of the object is acting. The weight of the object is acting downwards. That point on that object is what is called as the center of gravity. So it's what? It is a point on the object where the entire weight of the object is acting. Now, generally, have you ever seen these? Especially if you, how many of you have been to a circus before? How many of you have been to a circus? No? Any one of you guys who have ever visited a circus before, like a circus, like maybe near your house or something? I've done it once in my life, but how many of you guys have done it? Any one of you guys have visited a circus? Like, have you ever seen those, the balancing act? Those balancing act where the person is, balancing things on his head, or he's standing in a very weird position. You've probably seen that, no? How do they do that? You find the center of gravity of that object. Once you find the center of gravity of that object, basically the weight of the object is acting over that. So if you were to balance, if you just put some weight on that, that is more than enough. If you just put an axis on that, you will be able to balance the entire thing on particularly that particular point. So basically the center of gravity is nothing but the point where the entire weight is acting. So that is the point that generally people who are doing circus, or when you're balancing something, you find that center of gravity, and basically that's how you balance something. So for planet Earth also, it also has a center of gravity, or this, yeah, basically the center of the Earth, basically in the core, that is the center of gravity. And every object that you're tossing up, you're actually not, see, the earth is not pulling it towards the surface of the earth. No, gravitational force is not pulling any object to the surface of the earth, but rather it is pulling it towards the center of gravity. That is what is truly happening over here, right? So center of gravity is nothing but it is related to the gravitational force and the weight of the object, because again, what is weight? It is nothing but the force applied on the object by which the earth is pulling, the force by which the earth is pulling it towards the center of gravity. That is what is the weight. So basically it is a relationship between that. And more importantly, guys, sometimes people get confused between center of gravity and center of mass. Let me tell you that first. See guys, center of mass is nothing but the point on that object where the entire mass is acting. The mass of the object is acting, that is center of mass. Center of gravity is nothing but where the weight is acting. Now the fact is, for most objects, the center of gravity and center of mass will be very, very close to each other. Will be very, very close generally. So on the center of gravity itself, you'll have center of mass as well. Because of this reason, they interchange this word. So if you ever hear the word center of gravity or center of mass, it's not two different things. Because it's very, very close to each other, we can take it as the same thing. So sometimes they'll try to confuse you by asking you the center of mass. It's the exact same thing. Don't get confused. Don't start panicking again. Don't start thinking it's something that I've not studied. Center of gravity and center of mass means the same thing, because so it is two different things, but then generally it's on the same point. So you can consider they interplay. It's like a play with words. Sometimes they'll call it a center of gravity, sometimes they'll call it as center of mass. So people, that's the center of gravity at this. So for a body, if you are found at the center of gravity, that on that particular point, the torque and from the sum of the masses, the torque that is produced at that point would be zero. That is why you're able to balance it. That is how you're able to balance that object, because the torque about that point is going to be zero. So if you have to find out the center of mass, so again the formula is very simple. The sum of clockwise moment about the center of mass is equal to the sum of anti-clockwise moment about the center of mass. So that's how you find out the position of the center of mass. If you want to find the position, this is how you do it. The sum, it's the exact same thing like we did before itself. Just like principle of moments at equilibrium, this is also the same thing. Sum of the clockwise moment about the center of mass and is equal to the sum of anti-clockwise moment about the center of mass. You'll be able to find out what is the position of the center of mass for an object. Now, to talk about symmetric object. Now again guys, like I told you, center of mass and center of gravity is pretty much the same thing. So if you ever see this interchange of words, again please don't panic, it's the same thing because it'll be on the same point. Generally it is taken as the same thing. For symmetric object, symmetric means exactly, you know, half, like you can fold it and basically when you unfold it, it's basically the same side. So for symmetric objects, generally it will be at the center of the object itself. For example, if it's a circle, it'll be the center of the circle. If we talk about a triangle, you know, the basically if you if you take the midpoints of these three sides and wherever it meets, that will be the center of the triangle. So that would be the basically the center of gravity or the center of mass as well. For a rectangle, the diagonal, and for the triangle also will be the diagonal. So wherever the diagonal meets, that point will be the center of mass. So for if you talk about every other, you know, symmetric object, it's going to be exactly the center itself. But for non-symmetric object, it's going to be a little different. That is, an irregular shaped object will be a little different. So what you have to do is you have to take several points. So what you generally do is you take a point, and then you take a, you know, that take a stone or something, tie it to a thread and then leave it hanging. So mark a line over that. So do it like that for 3 to 4 times, about 3 to 4 times. Do it in all the different directions. So you have to you know, hold that point, like take a pin, stick it, and then take a thread and then tie a, you know, stone at the end of it, and then keep it hanging. Just let it easily, just let it freely rotate. So once it comes to a state of rest, draw a line and do that 5 to 6 times. Wherever it meets, that will be the center of mass for, or the center of gravity for an irregular shaped object. Now you don't have to worry too much about it because you will be doing this experiment in your 12th grade. You'll understand a little bit more about it in your 12th grade. In your 10th grade, it's not as much as it is, you know, it is not that required. All right. So yeah, people, with that said, let's get back to the topic. So quickly join the Mentimeter once again. I am actually extending the time, people. I have another session right after this. So let's quickly do it. The 6th question, let's do this. And then we also have center of gravity as well. So the circular motion as well. So quickly join the Mentimeter. I'll be starting the quiz in 5, 4, 3, 2, 1. Let's go. We will quickly join it because I have another session right after this. So I have to hurry it up a little. The incorrect statement. Which of this is an incorrect statement? Quickly read the question and then answer. The question is, a body can be balanced at its center of gravity. The total weight of the body acts as the center of gravity. The algebraic sum of moments of the weight of all particles constituting a body is zero about its center of gravity. The center of gravity of the body does not depend on how it is placed. Which of this is not true? Which of this is incorrect? Read the question and then answer. Go ahead, people. Let's go. No, why would I be angry? No, I did not read the chat all this while because I wanted to finish it off. That is why. Suresh, perpendicular is nothing but 90 degrees. No? That is what is perpendicular. Mathematics, perpendicular. Parallel, perpendicular. Yeah, 90 degrees. That's what perpendicular is all about. All right, let's go. Did I miss out any of the doubts, people? I'm really sorry. I haven't been reading the chat at all. Anyways, 8 of you guys were able to give the right answer for this question. A lot of you guys went with different answers. But yeah, people, all the other statements are correct. Yes, center of gravity. You can balance the body at the center of gravity. I told you, you can generally balance the body at the center of gravity if you find it. And secondly, the weight of the body is acting at center of gravity. I've already stated that as well. And yes, to find out the center of gravity, I told you that the torque above that point would be zero. That is, the sum of clockwise movement would be equal to the sum of anti-clockwise movement as well. So the torque would also be zero. The one statement that is not true is that center of gravity does not depend on how it is placed. Definitely, it depends on how it is placed. For example, people, if I have a cube, let's say this is a cube. Now, you cannot, you know, expect the center of gravity. If I place it like this, do you think I'll be able to balance it this way? I might be able to find it, but it will be much more difficult. But if I find the diagonal, it will be a lot more easier. So how it is placed definitely matters when you talk about balancing or finding out the center of gravity, because it is something that determines whether that body can be balanced in that position or not. All right, so let's quickly do this. Circular motion. We have 2 more topics left. Let's quickly do that and finish it off. All right, circular motion, uniform circular motion. When a body is basically moving with a constant speed in a circular track or in a circular, path, that is what is called as uniform circular motion. But the speed has to be constant. That is what matters. Speed has to be constant and it's going round and round. In other words, it's going in a circular track. That is what is called as uniform circular motion. Now, the fact is, people, all this while in your lower grades, you've understood that when a body is moving in uniform circular motion, you consider that we've never considered the direction. We always consider the magnitude. We always consider the magnitude of the speed or the magnitude of velocity, but we never considered the direction. But if you think about it, people, every single point, the direction is changing. Every single point. So you have infinite change in direction happening when a body is moving in a circular point. Yes or no? Do you guys agree with me on that? First of all, because the body is going round and round. Look at that person going round and round. You see that at every single point the direction is changing. So what we're doing is that, see guys, velocity is what? The rate of change of speed, or displacement, rate of change of displacement. That is what is velocity. So in displacement is a vector quantity, which means we consider the direction as well. So here what we are doing is that because the direction is changing at every single point, we are saying that the velocity is also changing because the direction is changing. Because obviously displacement is something which considers the direction as well. So if the direction is changing, obviously displacement is also changing. So if displacement is changing, then velocity is also changing because the direction is changing at every single point. So if the body's velocity is changing, then you can claim that the body is accelerating, or in other words, you see an accelerated motion. This is what, so you can call it as uniform accelerated motion depending on what the velocity is. So people, let's come back to the quiz later. Let me just finish off the topic first. Now, there are two types of forces that is acting on a body that is moving in circular path. One is the centripetal force, the other is the centrifugal force. What are these? Let me quickly finish off. This is the last topic. Listen up carefully. Centripetal force is nothing but, for example, let's say I have a stone, all right, I've tied it to a thread and I'm like rotating it, okay, I'm constantly rotating it. So when a body is accelerated, obviously, again, because the velocity is changing, it's obviously accelerating. You can say that the body is accelerated. Now, for the body to accelerate, there should be some force according to Newton's second law of motion, that is F is equal to mass into acceleration. Acceleration is what? Force by mass. So there should be some force acting on it. Only then the body can accelerate. Yes, that is you cannot defy that. The body has to follow Newton's law of motion. So obviously here also it is the same. So there should be some force acting on it. So there is one force that is acting towards the center of the thread. There's a force acting towards the center. That force that is acting towards the center, or the center seeking force, is what is called as the centripetal force. This is called as the centripetal force. So this is what keeps it in circular motion. Now, if there is a force acting towards the center, there should be a force acting in the opposite direction as well. According to third law of motion, that has to be there. For every action there's an equal and opposite reaction. So the force, if there's a force acting towards the center, there should be a force acting in the opposite direction as well. That force that is acting away from the center, that is called as the centrifugal force. The force that is acting away from the center. Now all of this force is caused because of the tension on the wire. The tension that is there on the cable has the wire that I've tied the stone to has some tension on it. That tension is what is causing that force. It is causing the object to, see, there is a force acting towards the center, that is called the centripetal force. And there's another force that is acting away from the center, that is called the centrifugal force. And because of both these forces, that is why the stone keeps on rotating about that same circular point. It keeps on rotating in that circular direction. So why? Because both these forces are acting in the opposite direction, making sure that that body is going in the same circular path. And this is how, people, even the earth is rotating about the sun, about its axis. The sun is not, pulling the earth towards the, in the sense, yes, the earth is not going towards the sun right now because of the centripetal and centrifugal force itself. Right, guys? So that completes the topic for today. So if you have to talk about how do you define centrifugal force, it is nothing but the apparent force that is felt by the object moving in a curved path, again outwardly. Obviously, again guys, it's an apparent force. It's not actually true. It does not really exist because, again, according to Newton's law of motion, there should be an equal and opposite force. That is why we consider it centrifugal force. But it's not actually there. It's an apparent force that is there to counteract that centripetal force that is acting towards the center. Because if there was only centripetal force, what would have happened? The stone would have come and hit me. But that is not happening. The stone continues to rotate in that same position, or the earth is continuing to rotate in a circular path around the earth because of this counteractive force that is called as a centrifugal force. Right, guys? Did everyone attend? Did everyone understand this, people? Is it clear? Yes. Is it clear, people? Is it clear? So that pretty much is it, guys. That's it. I know it's been a long ride. So we have 3 minutes left. Let's quickly do the quizzes as well. We have two more questions. Let's quickly do that and finish it off, people. I hope you understood everything. I know I've been rushing it up a little because the thing is that, people, I have another session at 6 o'clock, so I have to attend that as well. Obviously, I can't just stay here. That is a problem. So that is why I have to rush up a little. 2 minutes left. Let's quickly do it. Keshav, Dhriti, Joseph, okay, let's get back to the this thing later. Quickly. Eighth question, people. Seventh question. Two more questions. We're almost done. This is the seventh question. Take a look at this one. Quickly join it. Quickly join the Mentimeter. Solve the question as well. The velocity of a particle moving in a uniform circular motion at any point is directed. The velocity of a particle moving along a circular path at any point is directed along the tangent drawn at the point towards the center, radially outwards, or the plane perpendicular to the circular motion. Let's go, guys. Come on, quickly. We have 2 minutes left. Let's quickly do it. Come on. People, any doubts? Alright, did I miss out any doubts? I know that I've missed out a lot of doubts. So class 10 of force and laws of motion. I know it's not there now, but Sarah, it does not mean that you should forget all of that. It does not mean that laws of motion, you can just forget it. That is going to haunt you for the rest of your life. Trust me, it's not going to leave you at all. Nonetheless, almost done, people. Here we go. It is 11 of you guys were able to give the right answer. Exactly correct, people. It's always along the tangent. The velocity is always along the tangent. I told you the direction is changing. The displacement is changing at every single point. I showed it by the arrow mark. So displacement is changing at every point. So obviously the velocity is also in the same direction. It will be a tangent to that particular point. All right. Next question, people. Last question for today. Let's finish it off with this, and then we'll also take a look at the final leaderboard as well. Here is your last question. Last and the final question. The question is, a piece of stone is tied at the end of a thread and is whirled in a horizontal circle. Name the force which provides the centripetal force. Name the force which provides the centripetal force. The force of tension on the thread, the radial force acting on the thread, the force of stone on the thread, or the force exerted at the end of the thread. What is the one that is providing that centripetal force? What force is providing that centripetal force? Is it the tension on the thread? Is it the radial force of the thread? Is it the force on the stone on the thread? Force of the stone on the thread, or force exerted by the end of the thread? Let's go, guys. Come on, quickly. Quickly answer the question, quickly. Yeah, Sunita will be coming up with that also. I think next there's one more one shot video that'll be coming up. Will be coming out with that soon. So don't worry. All the chapters one shot will be done. So don't worry about that. 16. That is probably the highest that we have gotten, and that was unfortunately that was the last question. Thank you, people. Thank you. At least one good answer, one good result we got. And yes, the right answer is because the tension on the thread, the tension of the thread is what is causing that centripetal force. Congratulations, well done. So here is your final leaderboard. I think Keshav is the winner for today. Congratulations, Keshav, followed by Dhriti, then it's Joseph, then it's Kwahish, then it's Chaitanya, I think, then it's Shreya, Kushi, Purya, and then Ganesh and AK as well. Congratulations, people. Well done. That is it from my side. Thanks a lot for joining today's session, people. This is your leaderboard. Yes, I'll be putting it up in the community page, so don't worry about it. Thank you for joining, guys. I really have to leave right now because the time is already 6:01. I have to go for another session. Thank you for joining. I hope you enjoyed it. I hope you learned something new out of today's session. If you liked the video, do not forget to hit that like button, because obviously we've spent 1 hour completing the entire chapter. If you like it, hit that like button. Don't be conjuice about it. Yeah, it's not gonna you're not gonna lose any money out of it. So please do that and subscribe to the channel as well. And if you have any doubts, do let me know. You can reach out to me personally if you want to. My email ID is anoop.maronan@vedantu.com. So once again, let me just open that up. So that's it, people. That is it from my side. Once again, the coupon code is AMEPRO to avail the discounts. It's given in the description below. Click on that link and do that. So bye, people. Once again, congratulations, everyone. I'll see you guys in the next one. Take care of yourself. Stay safe. And bye. See you all, guys. Take care now. Bye, guys. See you all in the next one. Take care of yourself. Enjoy. Bye. Good night. Have a nice evening. Bye. See you all.